for this one. Okay, now we are entering the third unit. That is an information modeling. I can say it's an topic itself is covers. It's a third unit, information modeling for TMN. That is a telecommunication management network. That is an information modeling for TMN. This unit covers what is an information model, and what is the requirements for information model. That is a simple thing. Rationally is going to be a supporting thing which says why we need an information modeling. Then what is a management information model? What do you mean by management information model? Then object oriented modeling paradigm. It says you can have an information model. Information model doesn't mean that it has been you are confining that model to the network, telegram network, a telecommunication network, a network management and anything. Any events, anything which carries an information and it has been defined in a particular model, then you call it up as an information model. That is what they have given in this one. So the next one is structure of the information management information. We are getting into the management side. Then we are saying what is the structure, how it can be framed, the framework can be designed or framework can be defined for these telecommunication network information. Management object class, how the class is defined, and what is an information base, MIB is going to be, what is your MIB and how it has been defined. That's a simple thing, right? What is a core understanding of this unit is going to be information model is a common thing for every computer level subjects. If you go for a database, if you say I'm having an information model, definitely your directory is going to be an information model. How you are framing the directory is going to be decided by what is the purpose you are having it up, how you are going to approach a model, and how much you want to retrieve the information or change the information in a frequent way. There it requires how you are framing the model. So information modeling model is not an one term which is going to be applicable for the telecommunication network. It is a common term which was already applied in every context of the computer systems, which is going to be the database side, or it's going to be the OS side, or any of the sites, software development. You call it up in the software development side. Now the big data has been working on everything or if you go for a website, you need a repository to put it up. If I call it up as a repository or collection of something, some objects which can be represented in this one, I cannot call it up an object because it is not very much confined with the object-oriented manner. We are speaking about the information modeling, right? That a common terminology which can be applicable more or less in the software development, right? But why they have adapted in this one, in this network modeling? This very concept has been introduced by Flavin. Right? He is the one who introduced the information modeling, not anything that is a common fundamental. He has designed a book and he said, this is a common thing which is available in this one here. Then there is a need for information modeling in this telecommunication architecture or the network, right? This rationale for information modeling says the major goal of the telecommunication architecture is interoperability. How we are going to make the information modeling in the for the network management alone. Then we are going to have a communication between two application entities for the common understanding of the information exchange irrespective of the application. That is one thing we are going to clear. What is the application? This a normal information model is going to have a communication, and that model has been derived by the entity itself. So how the communication happens between the entity, what they are communicating, how the understanding should be happen between these two entities, and what is the model which has been, information model has been derived on the entities, and how the communication happens is the whole called as an information model then, right? Now it's a common thing, so we cannot put it across or we cannot confine into telecommunication or the network management, because it's one of the application happens to be run on the application layer level, right? This is a common thing which we goes across in this one. So before we go into the information modeling, I just want to know how the application layer data has been put across, who will involve in all those things that, right? We are going to see the same thing we have seen earlier in the unit 2, whatever the content we have seen in the earlier 2, that has been going to pull inside this unit little bit manner. I'll just explain how the application layer frame the PDU, right? You might see it in the last one, or you never get to know about how the application layer put up at the PDUs, because that is not normally, that is not part of your computer network. It comes in the later when you want to learn it up something, then you go across and learn it up on your own, right? Now we are seeing it up. This I will get back to you. First, I want to explain how the message will go across. Then only you come to know why, what is the need for an information model. This is a normal TNM, not leave it up as a TNM message. This is a management message which comes across there. Here we are having a lower level protocol, which is an ACSC, which runs in the application layer. It never sends any, it's only trying to establish a communication. So there is no need to send it up as a PDU or a packet data has been across any of this unit itself. Then there is an above, it's a rows is going to be run across. Remember one thing, ACS or rows, it's SMAS is not going to be, SMAS and CMSC has a very particular network management. These two are common relevant communication protocols which runs on the application layer. I can apply for any of those applications, which has been supported by the OSA reference model. That's all. So we are going to have an ACSC, we are going to have an rows as an PDU. These first two will be filled by the rows. Normally it would happen there. The sequence number and the operation will fill by normally by these rows. After that, it never fills any packet, or in the placeholders will be available for further protocol to fill it up. Only two things the rows will fill it up, because rows comes to know the two things is important for their communication. That's all. They never bother about remaining one. What are the numbers? Sequence number, then what are the operation you are going to run across in this one. That's all. Relevant to the operation, some other things it never bother about solving. So the first two will be filled by the rows protocol. Then the CMSA carries the remaining 3 out of 4. It's fill the 3 parts from the 4, and it goes to the SMAS. The remaining thing is going to be fabric ID, not the remaining. That 3 out of 4 is going to be fabric ID. What is an ID? It's a fabric one. So we are going to speak about the fabric switch. So it's called the fabric ID. Then event. What is an event? It's an event. Then what is this severity will be left over there, right? So what happens here is this 3 will be filled. This will be left over by for the SMAS to fill it up there. SMAS is going to be what is the cause and what is the severity is going to be there. Here we see the next one. Why I am explaining all those things is this information which we are passing is not particular to the individual network management. Some remaining information is going to be for application oriented. So whatever application comes across, it will work for that application. Some are going to be reside on the application layer, which works for the application layer. So these two communication ACS and rows most of the time can support some other application, which is most probably looks upon the looks like network management or some of the transferring information. That is a good thing. But above that is CMSC defines something and SMAS maintain. Then they have given a 2 subtree, right? This subtree is a very, very, very important subtree. Now I will complete this one and get back to the subtree. See, these first 2 will fill by the rows. Then the remaining is going to be 1, 2, 3, 4 times. These things are going to be filled by the CMISC. The last one, which is going to be SMAS, is going to fill it up. So it says what is a critical one, what is a failure. If suppose it can change it up, that also can be included in this one. So it's a very critical one. Board has failed here. This board is a fabric board. That is an ID is SRI. Then equipment alarm. The type is alarm. What is the type? What is a man class? What is an instance? Class instance. Remember a thing. Now we are getting into this one. This is a normal application message. We will pass it up between one another. Then who are all involved has been given here. How the application layer runs across. This packet will be set it up by the application layer, sent to the next lower level layer. It goes across this one. Remember a thing, every entity or every computer, every laptop carries, if it is runs on the OSA reference model, 7 layers within itself. Remember a thing. Not each entity will carry individual layers. Only routers and switches carry for 3 layers. Remaining every system where you are doing your application, where you are receiving an application, carries these 7 layers. If it is an internet suite, you carry it up 5 layers. That is already in your system itself. Your system normally you are running an internet suite, so they carry it up as a 5-layer. If suppose my system runs on a OSI model, reference model, OSI reference model, then definitely my system carries 7 layers. Whether the 7 layers work or not depends upon that thing. Routers switches never carry all those things. They carry only 3 layers because check it up whether it never open any application. It is not running any application. Its job is do some routing. So that is enough for you to run it up this one. So these 7 layers run in this one. Everything happens in the application layer. Pack it up as an application PDU. It's going to be a PDU. Based on all this protocol work happening here. What is the protocol? Is that the application is network management. We are speaking for the network management. So these things are involved, and pack it up. Put it to the below layer. Below layer will take care of the next level of adding some header and wrap it up in a better manner. Then below layer will add some header and wrap it up they have individual functionality. They will check it up their function. Not once a packet has been open at any of this level, right? Unless the packet has been meant for the system alone. If the mail is for me, I am allowed to open the mail on my application of mailing application. Otherwise, I am not supposed to open the mail because it never forwarded to my application layer. Once a packet reach my application layer, then only I can able to open it in my application, mailing application. Otherwise, I cannot able to open one. If it is meant for some other one, and if it is passes through my system, it never put it across, open it up, or it never allow cross over the network layer to reach it up my application layer. So this is a thing would normally happen in your computer sites, network side. So now we are having 2 trees upon that one. Here, this is a tree which has been put across. This is a tree which has been put across in this one. There are 2 entities. They are working, the communication happening between these 2 things. What happens is the same setup has been put across these things. So what we are going to say it up, how it could identify this is the event reply has been applicable to the whatever. I can identify what is the request or what is the reply it is giving it up based on that tree I have designed in myself. If both the tree is same or they know where the object stands or object instance stands on the tree, then only they can be able to recognize what it has been sent by the other person, other entity. So it happens to be, we are going to see how this model has been designed here. That is called even information model here. In the context of network management, information model should be look like a tree. You can frame it up in an object-oriented manner. Right? There are so many manners you can put across. It need not to be in an object-oriented manner. SNMP never carries it up in object-oriented manners. It's an object-based manner. So it can go across a different way. We can put it up. But here, this network management based on the OSI reference model, we call it up in an object-oriented manner. So this object-oriented modeling, how we are going to define it up, what are the classes, how we are going to set it up. These are the classes I am going to put across, and these are the instance I will create it up there. These are the parameters I say which could be common to everyone or which is not going to common everyone. What are the interface I can use it up to pass on the information. All this information comes across in the modeling side. That is why we have to learn how the information has been modeled in this one. Information modeling could be common to SNMP as well as your telecommunication, TNM. But implementation is going to be different because another thing is they frame it up in a way, but half of the relationship happening between these things, these one another object is not going to be same in the TNM and SNMP. Why it is so? Here what we are doing it up. You have come across a diagram, ER diagram, right? Normally, the ER diagram is going to be an entity relationship. It explains the entity relationship known as an ER diagram. That is going to be it has been created by Chen. You have later developed into the chart has been given in the relationship side. So what is the relationship between any entity? How the relationship could be established in this one? That we are differing from TNM to SNMP. Right? SNMP is an object-based one. It's an object-oriented one. So the relationship plays a heavy role in this one. So once I can able to establish a relation between one object instance to another object instance, or within myself, within my object, it's a parallel object instance, or I can say it a siblings of the tree, one tree, and it's going to across. The difference between both the siblings is going to be based on the relationship. Then it can be highly efficient one to establish through this TNM manner rather than your SNMP object based manner in this one. Okay, we are having a year diagram, everything is fine. So what is it this carries in here? Here we are going to see what is an information model. This I have given for the purpose of how it will package it up and what we are learning from this one. We are not going to learn how this, we have already seen what is on rows, what is the CMIC, what is SNMAS and CMAS, what is the purpose and how they are sending it up, and what is the data filling happening it up. Now we are moving towards what is an information model, how they have been put it across as a relation, and how they have been store it up as an entity, or how this relationship diagram has been created from this one. It carries from the software development side. We are not saying we have created everything. It's already, it has been available in the software architecture, how you can create an ER model. ER model has been running around the world mostly more than 20 years because it knows how to put across the entity relationship models in a better manner in this one. So the entity relationship can be modeled using the ER model. That model has been created earlier. So it will be easy for us to observe that thing from that one and frame our information model. Remember, I think the purpose is to frame our information model for that one. So we are framing our information model using the resources available within us. Remember another thing, we are here speaking about the resources, right? Whether we speak about the switches, whether we speak about the routers, it could be a physical entity or it could be a logical entity. Logical entity is going to be the transmission line. I can say it a transmission, end transmissions are the endpoints one. They are not the physical one, we can call it up. We can call it up as a logical one. So either it can be a physical or logical one. Then what happens here is a physical entity, you can easily explain that one because it has a physical one, it has some characters, it has some relation. But logical one, you have to explain in a proper way. So how I can relate physical and logical one? It's like a body connection with your soul. You cannot explain the soul, but the soul is that, we can say it. So the thing is how we are interconnecting, having a relationship so that you can explain or you can send a reply that could be understood by the entity who was asked in the request. So common model, information model is going to be a bigger issue here. We have what we have thought is, ER is available already in that scenario or already available in the technology side. We can create a whole thing in an object-oriented manner. Already you have come to know what is an object-oriented. Concepts are available in this one. That is, you have learned it up in a C++. Remember a thing, C++ is a language for object-oriented creation of any of this object, right? It doesn't mean that Java and C++ is going to be they are the expressing tools which has been used for object-oriented manner. That is that we can say it. It is an expressing tools, we can call it up. That tool can be expressed in a better manner, in an English way, and it's a machine languageable conversion, everything happens there. But modeling should come from our logical side, right? How we are creating the model, how we can write it up, or you can make it up, the system to understand is through your C++ or Java language. That is the thing, right? They have the language methodology, or you can call it up, the language has been created to support the object-oriented manner, so that they are call it up object-oriented languages. That is the term they are given. So it is easy for nowadays, we can represent an object in object-oriented way using the language which is available for the same purpose. We put it across, it's a C++, a Java. Most of the time nowadays, it's a Java is supporting all those things. That is why this TNM model can be easily established in a web-based automation thing. Because it's a Java is supporting the web-based, so it can be carried out because everything is in. But when you go for an SNMP, it is not an object-oriented way, it's object-based. We will see in the next unit how it is differ from that one. Even though you come to know what are the properties and what are the characteristics of each individual resources, which has been identified both the ISO layer as well, because network is a common thing. Whatever layer it comes across, network is a common thing. I have a router in the reference model. I can have a router in the internet suite also. It's a common thing. But how these things have been implemented, model has been represented is a little bit different here. So we can call it up a represent, and we do the working on this thing based on the model has been created here. Right? Now we are getting into, we just come to know what is a management, information management, because it's a simple thing. It's in software engineering. It's a representation of concepts and the relationship. Remember, I think constraints, rules, and operation to specify data semantics for a chosen domain of disclosure. Right? I have taken it from the Wikipedia. It's a simple thing they have given. What is in a software engineering? Remember a thing. Information model is a common thing. That's a model is a common. How I am doing it up in this one, what is the purpose of doing it is sharing information and creating an information model. That is important. Before we have to share anything, we just want to know what is an information model, how it has been created, so that everyone should understand. Suppose I create an instance of that object which is in the information model side, then what are the things it can carry it up from the parent side? What are the changes I can make it up there? These things are should be very clear for the network management side. Here, the software side, they explain information model in engineering is the representation of concepts. We come to know what is the base resources concept and their relationship. What are the constraints? If you want, you put it up the rules. If you want the operation, that operation definitely going to up. Operations, specify data, to specify data semantics. That is the important thing. It should be very, very meaningful so that we can put across. Without any meaningful, there is no need to add it up any characteristics are the operation in this one. It specifies relations between kinds of things, but may also include relations with the individual things. That is the thing. The relationship ER diagram is very much involved in this one. They represent how the relationship is going to be worked on this one. So the information model provides a framework for organizing the content so that it can be delivered and reused in a variety of innovative ways. That is typically a network management information model, because it is providing a framework, but organizing the content, how I will frame it, how I will name it up, how I will put it up, what are the things I should put it up in the object, then it can be delivered and reused. In a sense, if I create it up an instance of an object, how I will apply that one. That is the framework. Create an information model for the content repository. Another thing is repository. We cannot create a model and leave it up, say, this is a way you can communicate. But what is the purpose of creating it up? Can I have a repository based on that one, so that a later stage I can, because if you are calling for a log information, if you are collecting some log information, it's a information coming from some of the resources. So what is the purpose of log information? You are not going to work on it up immediately. You need a repository, store it up and put it across there, because alarm is one thing which you have to work it up on immediately. Something happens there, something broken or some fault occurs, alarm can be initiated, then you have work on it up there. But when you collected a log information proactively, periodically you can call it up, then where I will put it up, how the repository should represent these based on this information model in this one. That is a bigger question. Using the database is going to be a higher question, because that is helpful for the managing all the network elements. So that is a repository. Label the information in way that will enhance the search and retrieval. So the information model is the ultimate content management tool. Whatever the management tool comes across, that is a very content management tool, right? We are going to work it up in the object-oriented manner. It is not only the paradigm is going to be in a different way, it's an object-oriented way. Here, if you go for the TNM, information model is a clearly defined, firmly established manager or agent will be on the fast track, finding, retrieving, setting, and notifying the information they need. That's a simple thing. Unless you establish a proper way of doing work, you cannot able to retrieve all this. That is your for the purpose of doing your information model in this one, right? Now we are going to the architectures using object-oriented concept at different levels of abstraction based on agent model. Remember one thing, the term they have used it, different levels of abstractions. So what do you mean by an abstractions? Right? It is not a very clear one. Abstraction is a generic way of presenting one thing there. It's a very abstract one. If you can reuse it up using an instance and add it up something in this one, you can go across that one. The object can have an instance and you can put the object and name and anything. So these abstractions should cover what are the resources, what is the resources we are having it up, and how the resources can be reused or established as an instance, and what are things it needed up in the object side. So creating a different level abstraction is not an easy job. So that has been used in the TNM here. Right? Based on the manager agent model, that is a normal thing we come across. System management concept, that is, it uses OS system management, which has been established in X.700. Everything which you speak about here is either Maestro or X dot something number, some number, which is like a document, Paka document, you can call it up, or a very implemented document site, which is available in the net. You can go and search it up. Some of them are not available. They need some money to provide. But RFC is like not like an internet suite, which is having an RFC. It call it up RFC dot number. Here we call it X dot some number, right? They have a different numbers. For sometimes for the same thing, they can have the different numbers, or sometimes they put it up. They are these management system concepts has been always put in the exact something. SNMP have some of the RFC number. We'll see it up in the later classes. Now, this is a management operation or notification agent. This is what we have seen in the agent model, the manager agent model. This is the agent model. Remember one thing. That resources maintenance is going to be happen at the agent side. If suppose I am an agent, I am running anything, then I can have the resources within myself or connected with me, can have a link with me, relationship with me, so that I can able to retrieve some information. If suppose a manager, a above level manager asks me to send it up across or set the information there. Right? So these things should be the manager level, or I can call it at the higher managing side, should have a tree properly maintained, or repository it can maintain in a proper way, which has been established as a tree. Then only he can able to identify and fit something in this one, which has been retrieved from the agent side. Sorry. Here the managed object is physical or logical resources to be managed. There is a one question. Physical you can able to identify because I am having a router, I am having a switches, I am having anything in this one. But what about the logical one? Where I put my logical one in this one? It is a, I can call it a video model or the line printer. Anything I can. Printer is one thing, or line card is one thing, or a audio card is one thing. But if it is a logical one, it is going to be a log or cross connection map. I'm not going to explain what is a cross connection map. It will be come in the connection oriented side, switches has been connected and the cross connection will come across. But that is not part of your subject. But the thing is, log is very much familiar with you. So we will stick to the log at the logical side. If I speak it up a log as a logical side, we come to know even though it is a very particular thing for any of these action happening and this one, but it is not a physical thing we explain. It is a very logical one. So any physical entity or it can be a logical entity should be managed and the services could be utilized by both the sides, right? Suppose a logging alarm will reporting alarm, and some logging alarm will be go across in this one. They have to retrieve the history information it is not going to be allowable, or it is not available in the telecommunication service. Then they have to retrieve it up as a common abstraction way. How it is possible, right? These abstractions are sometimes in the two terms. One is managed objects, one is supported managed object. Why there is a managed object and supported managed objects, right? Managed objects, you come to know what are the objects available. You can go across and see it up. It's a normal managed entity. What is a supported one? How we can explain the supported one in this one? See, suppose I want to set it up, set a threshold value or change the routing information for one of the level connected with the entity along with this one. I can easily go and do the operation on this one. That is my manage object. I can change it up. I can put it up there and say, okay, fine. I want to, that manager asked the agent to change the values of the connected entity, which is a resources on your side, agent side. So it is a manage object. I can do it up in two ways. Manage object. That is fine. It will do according to the manager. Then supported manage object is one thing which has to be done on within itself. How it can do a supported thing. How we can create an abstraction in two types. Okay, abstraction need not to be a set it up based on the object side, manage object side. It can be do it up for the supported manage object side also. What mean by supported manager? See, I am setting an alarm in my system, or I am setting an alarm in your mobile to wake me up, right? That has been done within my system itself, right? Whether I am a manager or a agent, I am going to allow my event or alarming system to trigger when something happens, some threshold has been crossed over for my resources. So in that case, or I want to trigger a notification if something happens in this one. These things are called support and manage objects. So my abstraction, that management information abstraction which I used to create it up, should support these two activities. One is for the managed objects. Another one is called support and manage objects. So like this, you can have a abstraction for those things, and relationship between these abstractions should be very clear, so that you can establish a tree pakka way, and it can be supported in the management side or manager and in the repository also there. So why we need an information model there? That is a question. That is a question we have to very clear on this one. How the behavior is going to be, it's a very binding one, and how we are going to establish this one, right? We'll see an example in the later stage. Here, here they have given a manage object, encapsulate the underlying real resources, that is one managed object, enable its manipulation through well-defined operation, that you need it up. That, remember a thing, operation is a word, we can call it up as a normal methods in your C++ or Java, because it both supported the operation side here. Exhibit behavior at the object boundary, hiding resources, access details. Everything comes when I say it is a manage object, right? How the manage object should be happen is, you have an abstraction of physical or logical resources. Physical is definitely any resources which you can see in with your eye, that is a physical resources. Logical resources which is not seen your eye, only you can see it visible in a system itself, that is your log address, or it is going to be any notification, or even something that is going to be the event or the end system. It is going to be a these type of logical resources, and they have an abstraction for a managed object as well as support and manage objects also. So the encapsulation the underlying real resources, enabling its manipulation through well-defined operation, then exhibit behavior at the object boundary, hiding resources, access details. You cannot allow everyone to access your resources unless it has been, the permission has been set across them, right? Everything will be defined properly or modeled properly in a modeling manner, right? Then the support and manage object, what we have seen in this one is, not all manage objects represent resources. That is why what I said, there are managed objects that exist for the needs of the management system itself. There are logging, access control, notification. Logging also one of the access control, because I'm within my itself, I have to log it up there. So it is not any application I can use it for other people. I'm not asking it up. So logging, what is an access control for me? Then logging, then the control notification, that is your alarm notification. So two things has been abstraction supported. One thing is manage objects, another one is support and manage objects. So these two things has been properly defined, properly abstracted, so that I can establish a relationship once I create an an instance of an object and go through that. So remember a thing, here it is not a manage object or physically you see an object. There are manage objects that exist for the needs of the management system itself over the managing system. It could be an agent or it could be an, because agent is a one usually initiate the request for the notification. So that is a manager or this one, and they are control notification, logging, access control, or any of the triggering one, anything you put across on yourself, that is your manage, support and manage objects, right? This is your MIB, right? Here the MIB is all you come to know that the MIB is going to be a, I will this one before I go for I just want to give you an example of what is the properties of channel units. That's the channel is one of the things, we call it up as a physical channel. So I have a so many properties representation example I have given in this one, right? What are they representing here, right? I have a channel ID, vendor name, type. What is it? It is going to be the representation. Say it's a printable string. That is a different thing. Channel ID is some values. vendor name is going to be some values. It could be a string value. It's an integer. That is, it depends upon what type you are representing here. Then the type is going to be the what is the type of this channel, what it forwarded, and what are the things it will go across. Whether it's a multimedia channel or it's a data channel, it's a port channel, whichever channel you are using it up. That is why you have mentioned it up. What is the type? Then how many ports you are having it up there? It says, suppose I have a port and it's also an integer value. That much connection I can establish with the other one. The channel can have that much connection with the other entities available for this one. Port is, you come to know what is a port. Port carries some numbers in your computer network programming side. You come to know there are ports available. You write the ports because through ports only they will communicate with one another. Application goes one another. So the port implies you have a communication, not a channel. Within the channel, you have an opening. I can call it a door for within the channel. So how many doors you are having it up? How many doors have been open for you to have a communication? There are 4 doors open for the communication. Then assign ports, already you have assigned 2, remaining 2 are open to it. You can have a communication with the remaining 2. Or if suppose the assigned port has been relieved from that one, termination, then you can use that port also. Working status is whether it is in the working status or not. That is a Boolean one. Type is a Boolean one. You say yes or no, finding it whether it's a good or whether it is in a good condition or in not a repair condition. Then it's a replaceable. The term it's replaceable is yes. Why we are calling it up replaceable? See, suppose if there is any failure happens there, it could be replaceable as a single unit. In a sense, I can remove that unit alone and the full unit of the channel, that is a channel ID 0 integer, and replace it up as a single unit. If it is not, it can be reused or repairable, or I can remove only part of the unit and change it up is not. That says no in this one. It is replaceable in a sense. I can remove the full unit and replace it up this. Then alarm status. There are 3 alarm status they are given. They are integer. Well, 0 is critical, major, minor. It's a very clear. Sometimes a false alarm. That is the 3 thing we have given here. Version is going to be printable string. Version is given version. Serial number is common. So we have seen some properties for channel units, right? Where I will place it up these things. There will be a question asking. Whether I will put all those things in my object creation once an abstraction has been created, or it is going to be common to everyone. There will be a question you put across. I will stop at this one. Think all those things, because this is a normal. If you work on the network management side or network side, you definitely comes to know these are things are common. You enter in your programming side. So which are the things I put it across in the common one, common entity resources, and put it remaining in the add-on or additional to the external, right? I will stop up to this one. We'll see in the, if you have any question, you can ask me. If you have gone through something, you can ask me also.